students, in this class we will learn how we can solve this problem 2. In our previous class we learned how we can solve problem 1. Okay, so start to solve problem 2. Here we have to prove tan a whole divided by cot a plus tan a whole divided by 1 minus cot a plus cot a whole divided by 1 minus tan a is equals to either 1 plus tan a plus cot a or 1 plus sec a cosec a. Okay. So left hand side item is tan a whole divided by 1 minus cot a plus cot a whole divided by 1 minus tan. Okay. Now first of all we write tan a in terms of sin a and cos a and cot a in terms of cos a and sin a. So tan a is equals to sin a whole divided by cos a whole divided by 1 minus cos a by sin a plus cot a means cos a by sin a whole divided by 1 minus sin a by cos a. So sin a by cos a whole divided by, we can subtract the denominator after finding the LCM of the denominator of 1 and sin a. So this will give sin a minus cos a plus cos a by sin a whole divided by cos a becomes the LCM of the denominator and we get cos a minus sin a whole divided by cos. Okay. So now we can write the product form, and when this divide becomes product, then this term becomes its reciprocal. Same here, cos a by sin a into cos a by cos a minus sin a. So thus we get sin square a by cos a into sin a minus cos a plus cos square a by sin a into cos a minus sin a. So from this we can write, since a minus b is equals to negative of b minus a. So we can write a minus b in the form negative of b minus a. So by following this relation, the first thing will remain same. But the second term, that is cos square by sin into cos a minus sin a, can be written as by following this relation. So thus we get sin square a whole divided by cos a into sin a minus cos a. This minus and plus when multiplied we will get minus. So this becomes minus cos square a whole divided by sin a into sin A minus cos A. Okay. Now from this, that means from this to this. Now the LCM of the denominator becomes cos A sin A into sin A minus cos A. And the numerator becomes sin cube A minus cos cube A. Okay. Now we have to use an algebraic identity, which is a cube minus b cube equals to a minus b whole into a square plus ab plus b square. So by following this identity, we get sin cube a minus cos cube a as sin a minus cos a into sin square a plus sin a cos a plus cos square a whole divided by cos a into sin a minus cos a. Now cancelling this sin a minus cos a from numerator and denominator, we get sin square a plus sin a cos a plus cos square a whole divided by sin a cos a. Okay. Now after distributing, we get sin square a whole divided by sin a cos a plus sin a into cos a whole divided by sin a cos a plus cos square a whole divided by sin a into cos a. So we can cancel this. So after cancelling, we get sin a by cos a plus 1 plus cos a by sin a. Okay. Now all of you take some time to follow this procedure, and if there is some doubt, then you can text me in my channel. So by this sin a by cos a, we can write tan a plus 1 plus cot a. So this gives our first proof. Proof 1, or you can write first part of the proof arise. Okay. So to get the second proof from here, that means from this relation, this is say I. Okay. So to prove the second part, we can write from 1 tan a by 1 minus cot a plus cot a by 1 minus tan a equals to sin square A plus cos square A plus sin A cos A whole divided by sin A cos A. Okay, so this is named as 1. So to prove the second part, that is tan A by 1 minus cot A plus cot A by 1 minus tan A equals to 1 plus sec A into cosec A, we can write from this part of the proof 1 as tan A by 1 minus cot A plus cot A by 1 minus tan A equals to sin square A plus cos square A plus sin A cos A whole divided by sin A cos A. So from the trigonometric identity, we can write sin square A plus cos square A equals to 1, and this thing remains same, whole divided by sin A into cos A. Now we can distribute this as 1 by sin A cos A plus sin A cos A by sin A cos A. So this will give 1 by sin A into cos means cosec A into sec A plus 1. So this is the second part of the proof. Okay.